got quadrilaterals, but 6-1 is going to focus on all polygons. So first of all, what's a quadrilateral? 4 sides. It's a figure with 4 sides. Polygons are figures with more or less than 4 sides. Can you remember some things that have to be true about a figure for it to be a polygon? Or what's an example of a figure that's not a polygon? Okay. Good. So if it's open, if it's not closed, then it's not a polygon. What else? Is a circle a polygon? No. Why is a circle not a polygon? Okay, it's rounded, it's curves, it's not made up of line segments. So the first section is going to talk about just polygons in general. And then 6-2 through 6-6 are going to be just the quadrilaterals. So this section only applies to many types of polygons. You're going to have to classify them. So let's start right now. Turn your notes face down. Don't even look at them. So real quick, what is a 3-sided shape called? Triangle, 4 sides. Quadrilateral, 5 sides. Pentagon, 6 sides. Hexagon, 7 sides. Not septagon. Heptagon. Heptagon, 8 sides. Octagon, 9 sides. Nonagon, 10 sides. Decagon, 11 sides. We're going to call it an 11gon. You're not going to have it memorized, but it actually has a name. It's called a hendecagon. Don't have to worry about 11. 12, what's the name of a 12-sided polygon? Dodecagon. In your notes, when you look at your notes, you should see one chart. I'm going to come back to that. You should see one chart that looks like this. You can turn your notes back over. Does everybody see this chart? Okay, this is the one that you have to have memorized. You must know the names of these polygons. Then you'll see a chart next to it that's really tiny, and this is just because every year I have students who ask me, well, what's an 11-sided figure called? It's a hendecagon, but you don't have to have that memorized for me, okay? That's not one that your teachers usually teach you in the lower grades. And then just because some students want to know the names of all different kinds of shapes, I put that in there for you. You can Google it if you're interested in what is a 21-sided figure called or something that's not listed here. But this is just kind of for your information in case you're curious. You are not required to memorize any of these. You do not have to spell these correctly. You do have to spell these correctly, and the most common ones that are missed are heptagon and hexagon. So make sure that you can spell those correctly, okay? Any questions about those? All right, so you're going to have to classify it, which means tell me what the name of it is based on its sides. And then just some vocabulary. By the way, you still will have vocab tests. This chapter 6 has 17 words. Those are meant to be good grades. I hope they were for you most of the time last semester. If not, Quizlet, flashcards, study with a partner. Those are your great ways to study. All right, side of a polygon. If it says name the side of a polygon, somebody tell me what is one side in this picture. AE, that's a side. What's another side? AB. Remember when you name a side, back to chapter 1, you put line segments above them. Is BD a side? No, BD is a diagonal. Definition for diagonal is a segment that connects any two non-consecutive vertices. So what would be another diagonal? Say it again. BC or AC? BC? Oops, that's terrible. That didn't help. EC, what else? BE, what's another one? A what? AD? AC? Am I missing any? Is that it? Okay, so diagonals connect any two non-consecutive vertices. If they're consecutive, then those are the ones that make a side. And then the last vocab word here is vertex. What do we call it if there's more than one vertex? Vertices. And the vertices are going to be the points around your shape there, A, B, C, D, E. make sure when you name your shape that you're always going consecutively around your shape. So a common endpoint is a vertex. Okay, the next part of your notes are basically going to be trying to determine whether or not a polygon is regular, concave, or convex. And so we're going to learn some vocabulary there. But just a reminder, Elijah told us that a polygon has to be closed, has to be made up of segments, and just remember that they have to intersect at the end points. So this would not be a polygon because it's not intersecting at the end points. Okay? All right, so here's some vocabulary. I'm actually going to, we'll start here. So I'm going to come around the room. I'm going to call on you. The next several slides are just going to ask you, is this a polygon, yes or no? And if it is, what is its name based on its number of sides? So I'm going to give you maybe about 2 minutes. I want you to answer the next 4 slides on your paper, and then I'm going to go around the room. And you can talk with your partner if you want to, but answer the next 4. Polygon, yes or no? If it is, what's its name? Hands up if you've answered all 4. Okay, that was really less than 1 minute, so good job. All right, I'm going around the room. Let's start with Devin. Polygon, yes or no? Yes, it's a polygon. Preston, what's its name? Hexagon. All right, next one. Brendan, yes or no? Polygon. Yes. And David, what's its name? Heptagon. And again, make sure you spell that correctly. All right, next one. Jedi, polygon, yes or no? No, it's not. Why not? Very good. It's got curves, so it's not a polygon. And the last one here, Zach, polygon, yes or no? No. Jackson, why not? Not closed. All right. Any questions on what's a polygon? What's its name? Okay, pretty easy stuff. The next thing we're going to talk about is it regular, concave, or convex? So first of all, to be a regular polygon, it has to be both equilateral and equiangular. Both. So remember that equilateral means all sides are equal. Equiangular means all the angles are equal. Name a shape that we learned last semester that if it is equilateral, it is also always equiangular. Triangle. So a triangle that is equilateral is also equiangular, and so therefore it will be regular. So everybody with me? If it's equilateral, it is also equiangular, therefore it is regular. Okay? Name a quadrilateral that is regular. A square. So a square is equiangular and equilateral, so it is also regular. Name a quadrilateral that is only equilateral. What is the name of a 4-sided shape that has all equal sides? A rhombus. So be careful. In quadrilaterals, just because it's equilateral does not mean that it is also equiangular. That's only true for triangles. So a rhombus would not be regular. What is a quadrilateral that is only equiangular? Rectangle. And we're going to talk very specifically about all of the quadrilaterals in this chapter. So for it to be regular, it has to be both. A triangle, if it is equilateral, is always regular. But a quadrilateral could just be equilateral. Could just be equiangular, or it could be regular, depending on what shape it is. Okay, if it's not regular, we call it irregular with 2 R's. So regular versus irregular. The next vocabulary is concave versus convex. When I think of concave, non-geometry definition, I think of a shape caving in on itself. So instead of it being flat, you've got sides that are going inside your shape. So for example, this would be a concave quadrilateral. This would be a convex quadrilateral. Do you see how it's caving in? That's not the definition they're going to give you. The definition they're going to give you is it is concave if you can draw any diagonal and the diagonal lands outside the polygon. So even though this diagonal, oops, not that diagonal, that's not a diagonal. Even though this diagonal is inside the shape, because this diagonal is outside the shape, this is concave. But if you look at this one, every diagonal is inside the shape, so it's convex. So concave, I think of it as just caving in on itself. The vocabulary definition you need to know is if any diagonal is outside the shape, it is concave. If every diagonal is inside the shape, it is convex. Does that make sense? Okay. So convex diagonals are always inside. So no diagonals are outside. Okay, so again, I'm going to give you about a minute. You're going to go through the 2 that are on the page you're on, and the 3 that are on the next page. So the next 5 slides, you're going to answer, is it regular or irregular, concave or convex? You can talk it with your partner if you need to. Make sure you do all 5. So the 2 on the front, flip it over, the next 3 on the back. I'm going to give you another minute. Keep working. Hands up if you're done with all 5. Okay, we're going to start checking. Keep working if you're not. I'm going to start with this first example. Ethan, regular or irregular? The question I'm asking though is regular or irregular? Okay, it is equilateral, but is it also equiangular? No, notice that these have 2 marks, these only have 1 mark. To be regular, it has to be both equilateral and equiangular. So this would actually be irregular. Does that make sense? Okay. Jackson, concave or convex? Convex. It's not caving in anywhere. All diagonals are inside the shape. So it is convex. Irregular, convex. Next one. Let's go with Rachel. Irregular. It does look to be equiangular. However, we didn't look at these angles here and notice these angles inside are not going to be 90-degree angles. Also, it is not equilateral. So it is irregular. Shelby, concave or convex? Concave. Remember, you're thinking, is there anywhere on my shape that it's going inside of itself? Or if I connect any two non-consecutive vertices, are they outside the shape? And so all of these diagonals would be outside the shape. So they are concave. Next one, let's go with JP. Regular, irregular? Regular. It's both equilateral and equiangular. What is the name of this shape? It's a square. Good. And Zach, concave or convex? Convex. It is not caving in anywhere. Good. Regular, convex. Next one, Yesenia. Regular or irregular? Regular. Very good. And concave or convex, Dorothy? Convex. And the last one, let's go with Lily. Regular or irregular? Irregular. It is not equilateral. It is also not going to be equiangular. Concave or convex, Nicholas? Concave. It's caving in. Or again, if I were to connect these two, my diagonal is outside my shape. Any questions on those vocabulary words? All right, should be easy. The next thing we're going to do is investigate some formulas, and you're going to need to know these formulas for the test. You may want to jot down just real quick somewhere in your notes kind of a summary chart of the 4 formulas you're going to need to memorize. So what we're going to shift to talking about is interior angles and exterior angles. And I'm just going to kind of show you all of this up on the board, and then I'll kind of show you where it's at in your notes, okay? So if you'll just kind of ignore your notes for just a minute and look up at the board, we're going to kind of go through where this comes from. So first of all, reviewing. If I have, we'll start with the triangle. That's what we talked about a lot last semester. If I have a triangle here, what kind of angle is angle 1? Interior or exterior? Interior. Angle 2 then is an exterior angle. What do we know about the sum of an interior and an exterior that are side by side? They add to be 180. What kind of angles do we call these? Supplementary, because they add to be 180, but what are they? What's the name of these two angles? Linear pair. So this is a linear pair. They are supplementary. They do add to be 180. Every interior will be supplementary to its adjacent exterior angle. Are we all okay with that? Okay. So what they're going to do is they're going to ask you not just triangles this semester, but any polygon. They're going to want you to find the sum of all the interior angles. So remind me, for a triangle, what was the sum of the interior angles always going to equal? 180. Everybody okay with that? Do you know what the sum of all the angles for a quadrilateral is? Okay, here's some people saying 360, some not quite so sure. What about a pentagon? Does anybody know what the sum of all the angles in a pentagon is? Okay, so nobody really knows for the pentagon, and then I'm going to ask you things like, what's the sum of all the angles in a dodecagon? Or what's the sum of all the angles in a 100-sided figure? And you're going to have to know that answer. So what we're going to do is figure out how can we come up with a formula that will calculate the sum of all the angles based on the size of the shape. You already know it's 180 for a triangle, and we're going to start by using that information we already know. So let's go to the quadrilateral. Pick a vertex, any vertex on your quadrilateral, and we're going to draw in all the diagonals from that one vertex. Okay, so I've drawn a little quadrilateral here. If I go from this vertex and draw my diagonal, is there any other diagonal that I can draw from that vertex? No. So what did that split my quadrilateral into? How many triangles? 2. And we know that each triangle should add to be 180. So that means I can take 180 and multiply it by 2. And so what's the sum of all the angles in a quadrilateral? 360. Okay, let's go to the pentagon. Pick a vertex, one vertex, draw in all the diagonals from that one vertex. So do I go right here? No. Non-consecutive. So this would be a diagonal. This would be a diagonal. Are there any other ones? Nope. How many triangles did it form? 3. 1, 2, 3. So I can take 180 and multiply it by 3. What's the sum of all the angles in a pentagon? There are two different answers. What is it? 540. Okay, we'll do one more. Look at the hexagon. What do you think we're going to multiply 180 by for the hexagon? 4 is what I'm hearing. Let's go from one vertex, draw in all the diagonals. Are there any other diagonals? Nope. How many triangles did I form? 4. And so what is 180 times 4? 720. Okay, what do you notice that we're doing every time we add a side to the sum of the measures of all the angles? So when it was 3 sides, it was 180. When it was 4 sides, it was 360. 5 sides, 540. What are we doing every time we add a side? We're adding 180. So if I know that a triangle is 180, then a quadrilateral has to be 360, 180 more. 5 sides has to be 180 more. 6 sides has to be 180 more. Does everybody see we're adding one more triangle every time? Okay. So when it's 3, it is just 180. When it is 4, it is 180 times 2. When it is 5, it is 180 times 3. When it's 6, it's 180 times 4. What would be a formula that we could write down? Very good, Elijah. Josh, here's all your stuff, by the way. So notes, your hall passes, don't lose them. Those become your math card if you don't use them. Grade sheet for last semester. And then this was the final. I need that back, but you can look at it if you want to, okay? All right, so is everybody with Elijah that we are taking the number of sides minus 2. What's 3 minus 2? 1 times 180. Does that work for the triangle? The number of sides 4 minus 2 times 180. Does that work for the quadrilateral? And keep going. So the first formula that you're going to have to memorize is if you want to find the sum of all of the angles inside the shape, you're going to take the number of sides. We're going to call that n for number of sides. We're going to subtract 2, and we're going to multiply by 180. So if I say, what is a 100-sided figure's sum of all of its interior angles, you'll just plug in 100, subtract 2, multiply by 180. You get a calculator this semester, so that won't be difficult. Any questions? We all good? Okay, go back to the triangle. Last semester, we said that if our triangle was equilateral, it was also what? Equiangular. And today we said that means this triangle has a new word. What is it? Regular. Okay, if it is regular, how did we figure out what each angle would be if we knew the sum was 180? We divided by 3, which was the number of angles it had, or that's also the same as the number of sides that it has, right? So if it was regular, we did 180 and we divided it by 3, and that gave us each interior angle. Everybody with me there? And so what did we find out that the angles were if it was regular? 60. Okay, so today we're saying, well, what if it's not a triangle? What if it is a dodecagon, but it's regular? And I want to know what is the measure of each angle in a dodecagon. Then I'm simply going to use my second formula. So this is the first one you have to know. Here's the second one. If it is regular, only if it's regular, and you want to find each interior angle, so only if it's regular and you want to find each angle, we said all we have to do is take the sum and divide it by the number of sides. So here's our sum, n minus 2 times 180. What are we going to divide that by? Number of sides. And what represents the number of sides? N. So when it was a triangle, the answer was 180. And to find out each angle, we did 180 and we divided it by 3. If it is a quadrilateral, the sum's going to be 360. We'll take 360 and divide it by 4. If it's a pentagon, it's going to be 540. We'll take 540, we'll divide it by 5. We'll get each angle. Is this making sense? I'm sorry. Is this making sense? Sum of all the interior angles, and then if I want to know one interior angle, this is what I do. But only if it's regular. If it's not regular, I can't do this because they're not all the same. Okay, let's talk exterior. So back up here in my picture, this was exterior, right? So let's say that this is equiangular. What's the measure of the exterior angle out here? 120. Okay, now I'm going to extend this side out. Here's another exterior angle. What's its measure? 120. Extend this out. What's this angle's measure? 120. So first of all, if it's regular, what do you notice about all the exterior angles? They're all the same too, right? They're all equiangular as well. Okay, what is the sum of 120 plus 120 plus 120? 360. So the sum of the exterior is equal to 360. Okay, let's investigate just for a second. Let's go to the quadrilateral. In my quadrilateral, let's say that this is regular. So this is 90, 90, 90, 90. What is each exterior angle going to be? 90. Is everybody okay with me saying this is 90, this is 90, 90, 90, right? Because we said that an interior and an exterior are always supplementary. Okay, what is 90 plus 90 plus 90 plus 90? Careful. What is it? 360. So the sum of the exterior is 360. Let's try one more. This will take just a second. But let's say that this is, I'm going to make one that's not regular. So let's say that this is, just making up some numbers here, it needs to be 540. Oh, that's going to be dangerous. Let's just, actually I'll make it 100. 100, this is not drawn to scale. 100, 100, and 140. Is that 540? Okay. So here are my angles. What is this angle going to be? 80. What's this angle? This angle, this angle, and this last angle, 40. Okay, add them all together. What's 80 plus 80 plus 80 plus 80 plus 40? 360. What do you think that the sum of the exterior angles is always going to be? 360. It's not really a formula, it's just a fact that you need to memorize. If it's exterior, it doesn't matter if it has 3 sides or 1,000,000 sides. When you draw that shape, if you had 1,000,000 sides, it's just going to start to look more and more and more like a circle, and a circle is always 360. So the sum of the exterior angles is always going to be 360. Nothing to solve for, you just need to remember that it's always 360. But that's for exterior. Okay, last formula that you're going to need to know for this section is what if it's regular? And I want to know each exterior angle. So think about it with the triangle. We know the sum is 360. How could we have found each one of these exterior angles if they hadn't told us any information other than this is regular? Take 360, divide it by 3, and we would have got 120. Quadrilateral, we could have taken 360 and divided it by 4, and we would have gotten 90. So if it's regular and I want to know the each exterior angle's measure, I can just simply take the sum of all of them, 360, and divide it by what? N, the number of sides. Okay, just to summarize this and make sure it's really clear in your head to make it a little easier. Really, you have two formulas. If they're interior and I want to know the sum, I do n minus 2 times 180. If it's exterior and I want to know the sum, it's just 360. For each of them, if you want to know one angle, you just divide the sum by the number of sides. Is that okay? Okay, but this is only if it is regular. If it's not regular, we're going to talk about what to do. Okay, in your notes, all of this is listed. So here is the little chart where they investigated what we did on the board to come up with the formula. So here's that first formula that we wrote on the board, n minus 2 times 180 for the sum of the interior angles. And then we're going to start looking at some examples. The last two, numbers 2 and 4, are not in your notes. So make sure you wrote this down because these are not in your notes anywhere. The first two are, and I'll show you where the second one is here in a minute. Okay, so we're going to go through and kind of decide which formula should we use and solve some problems. So look for keywords. What are some keywords in this sentence that would tell us what to do? Sum, interior, what else? Heptagon. What is heptagon? How many sides? 7. It's convex. Anything else important? Okay, we're looking for the angle measures. So we want to find the sum of the interior angle measures in a 7-sided figure. How do we find the sum of interior angle measures? 7, say it. N minus 2 times 180. All right, so what is 7 minus 2? I don't know what is going on with this. Times 180. It's like drawing lines all through everything I write. What is 7 minus 2 times 180? What is it? 900. 900 what? Degrees. Make sure you put a degree symbol. You're giving me the sum of all the interior angles. Go to the next one. What are the keywords? Interior. What else? 16 gone. What else? Each. We're looking for each interior angle. What else is important? Regular. So we're looking for each interior angle, and it is regular. But we're looking at interior, not exterior. So what am I going to do to figure out each interior angle if it's regular and it's 16 gone? Exactly. The number of sides minus 2 times 180, that's going to tell us what the sum of all of them are. And then we're going to divide that by how many angles there are. N minus 2 times 180 divided by n. What's going to go in for n? 16. So 16 minus 2 times 180 divided by 16. Type it in. Tell me what you get. I heard 157.5. Somebody agree with JP? Jedi says yes. 157.5. Don't forget your degree symbol. Do not round. I'm going to emphasize that again. My rule in this class all year long will always be you should not round unless the directions tell you to round. So if you get home and you're working on problems, just because you get a calculator doesn't mean you get to start rounding your answers. You still have to use fractions. You still have to work with fractions and leave your answers in fraction form. So if you get something like 157.33333, what are you going to write as your answer? 157 and 1/3. You can use your calculator to help you work with fractions if you want to, but you still need to write them as exact answers. Don't round unless the directions tell you to round. Is that clear? Okay. All right, moving on. Let's look at this one. What are keywords? Each. What else? Interior. Pentagon. What's missing? Doesn't tell us that it's regular. We are looking for each angle inside the shape, but we don't know that it's regular. In fact, when I look at the picture, is it regular? Oops. Sorry. No, how do I know it's not regular? It's got different expressions for each angle. So it's not equal angular, therefore it is not regular. What did we do back first semester when we had a triangle and they told us this was 2x, 3x, and 4x, and we wanted to find x? Exactly. We added these up and we set them equal to 180. So 2x plus 3x plus 4x equals 180. Be careful. Most common mistake I'll see usually on this section is students will take and they'll add all these together, and what do you think they set them equal to? 180. Is this a triangle? No. Do the sum of all the angles in every polygon equal 180? No. That's what we just started out with, is this is how you find the sum. So you can't add these together and set them equal to 180. You're going to add them together and set them equal to what? 540. And if you don't know that it's 540 for a pentagon, then you're going to do this step first. You're going to say first, I need to find the sum. N minus 2 times 180. This has 5 sides, so you're going to plug in 5. And you end up with 3 times 180, which is 540. So first, you've got to figure out what should they add to be. Then you can do what we did last semester, and you can add all these together and set them equal to 540. Don't set them equal to 180 unless it's a triangle. Okay, be very careful. So let's do that. Let's add all these together. And set it equal to 540. So add all those C's together and tell me how many C's do we have? I heard 135 C's. Somebody agree with Jedi? Okay, so again, I'm just adding all the angles together, setting them equal to the sum of what they should be for the interior angles. So all of these add to be 135 C, and that should equal 540, not 180. What do I do to solve for C? Divide by 135. What is the value of C? 4. Any questions before we go further? I want to make sure I didn't lose anybody. Okay, is that my answer? No, what did it ask me to find? Each angle. So what do I have to do? I have to multiply, I have to plug it in and find each angle. Do I have to plug it in 5 times? No, luckily, a couple of the angles are the same, right? But I do have to plug it in and find every angle. So remember correct notation. You're looking for measure of angle A, measure of angle B, measure of angle C. Make sure you're putting those little measures in front when you write your answers. All right, A should be 35 times 4. What is that? 140. Don't forget your degree symbol. There's not another angle that was equal to A. B should have been 18 times 4, which is 72 degrees. What other angle is going to be 72? E. So then we don't have to show our work since we already did up here. C should be 32 times 4, which is what? 128. Don't forget your degree symbol. And angle D is the same, 128. Questions? Pretty easy? All right, just be careful because I promise somebody will set that equal to 180 if you're not careful. Hands up if I need to slow down and give you another minute or so. Okay. All right, this is where, I'm going to skip all that. This is where we talked about the sum should always be 360 if it's the exterior angles. And so now look at this next problem. What's the key words? Each. What else? 20 gone. What else? Exterior. Regular. So if it's regular, what do we know about all the angles? They're the same. If it's exterior, what do we know about the sum of all the angles? It's always 360. So we know they all had to be 360, and they should all be the same. So if I want to know what each angle is, I just take that sum and divide it by what? 20. In general, but in this case, 20. So what's 360 divided by 20? 18. Don't forget your degree symbol. So look for your keywords. Are we talking interior, exterior, sum, or each? And is it regular or not? All right. Look at this one. What's different on this one than the last one? Okay, it's not regular. What are they giving me in this picture? Exterior angles. And we know they're not all the same. So what are we going to do here to figure out the value of B? Okay, I heard a couple different people. We're going to add them all up and set them equal to 360 because the sum of the exterior angles is always 360. Go ahead and do that on your own. Figure out what B is. And then we'll check. And when you get that one done, look at example, the one next to it, and try it. So try the last two examples in your notes. And then we'll check them. Some of you are finished. Some of you are still thinking. Let me pull you back for just a second. What did you get for the value of B? Anybody? 3. So you should have, oops, that's not what I wanted to do. You should have added them all together, set them equal to 360. Remember, this is the part that I worry about the most. Are you setting it equal to the right value? It's only 180 if it's a triangle. If it's interior, if it's exterior, it's always 360 no matter what size shape you have. So be really careful. Add them all together, combine like terms. You should have gotten 120 divided by 120, and you ended up with B equals 3. Then watch what you're trying to find. If they just say find B, you're done. If they say plug it back in, be careful with notation as I'm walking around. I know it's just your notes, but if you were to do what I saw some of you doing on your paper, H and then whatever that was, 99 degrees, you're going to get points taken off because you didn't put an angle in front of it, and you didn't put a little m. Make sure you're putting the measure of the angle equals, okay? I don't want you to miss points for notation. Any questions on that one? Okay, last one here. Find the measure of angle 1. I don't like this problem for one reason, and that is they should have told you not only is this equilateral, but they should have told you it was also equiangular. In order to really work this problem, you had to know it was equiangular. Because remember, a triangle is the only one that's guaranteed if it's equilateral that it's also equiangular. Other shapes can be either just equilateral or just equiangular. Okay, so if it's regular, somebody tell me, what did you do to find angle 1? Should I? Okay, so where did you get 540 from? Okay, so he found the sum of the interior angles is 540. That would be either by memorization now because he already knows it, or by using his rule n minus 2 times 180. And then he said he took that 540 and divided by 5. That gives you one interior angle. And what did you get for one interior angle? 108. But that's not angle 1, so what did you do from there? Okay, so that gave him an interior, and we know that an interior and an exterior are a linear pair, supplementary. So 180 minus 108 was 72 degrees. Very good. Anybody see a different way you could have done it? Sean? Okay, so we're looking for, if we think about this as just the pentagon here, we're looking for this angle 1 that's out here. And that's an exterior angle. So you could just do the sum of all the angles outside is 360 and divide it by the number that there are 5, and you get 72. Does that make sense? Either way would work great. Questions? All right, that's 6-1. A lot of information, but it applies to all polygons. Okay, shift gears, look at 6-2. You need a clean sheet of paper. Hey Josh, when you came in, did you check in through the office when you came in? Okay. Did they give you like a little slip? No. Did they just say go on to class? Yeah. Okay. I'm just making sure because I marked you absent, so I didn't know what time you came in. Was it after 15 minutes? Okay. So just keep in mind, that's an absence. You don't want to miss more than 2. Okay. Just looking out for you. Okay. Everybody have a sheet of paper. If you don't, share with your neighbor if you like your neighbor. Or share with them even if you don't. Okay, everybody needs a sheet of paper. Okay, so here's what we're going to do. Chapter 6 is going to be about polygons. That's our 6-1. And then everything else is about quadrilaterals, which is only the 4-sided shapes. And we're going to talk about all kinds of quadrilaterals, and they're each going to have a bunch of properties. The hardest part for Chapter 6 is going to be memorizing all the properties for every shape and being able to apply them correctly. So what I would like for you to create starting today and through the rest of this week and next week is basically a properties list. So we're going to do that together. That's why I want you to have a sheet of paper. At the top of your paper, I would put properties. And that way when you go to study for your test, you'll have all of this in one place, all the properties you need. Okay? Today, 6-2 is going to be only about one of our quadrilaterals, and that is the parallelogram. So the first shape that we're going to be learning about is the parallelogram. Each shape is going to have a definition, which is going to be one of its properties, but you need to know which property is the actual definition. So every time we learn a new shape, I'm going to write underneath it all the properties, but I'm going to identify which one's the definition. Okay, because it's going to be important that you know which one's the definition when we get to the dreaded word, proofs. Okay, so when we talk about proofs, you're going to need to know whether it's the definition or just a property. Okay, all right, so parallelogram. First shape, and that's all 6-2 is about. So 6-2 is just the parallelogram. We're going to learn 5 properties about the parallelogram. And the first one is going to be its definition. So when you read the definition, besides the fact that it's a quadrilateral, what does it say a parallelogram has? 2 pairs of parallel sides. I'm going to write it this way. Not only do we have 2 pairs, but specifically they are the opposite sides. So it has opposite sides parallel. And I'm just going to use a little parallel symbol to save time. Remember, you can always use symbols in here. You have to spell things correctly, but you can use a symbol when we learn one. So that's always nice. Okay, so in a parallelogram, this is our shape. The opposite sides are going to be parallel. And remember, we use little arrows to show they're parallel. So those sides are parallel, and then I'll use 2 arrows to show the other pair of parallel sides are parallel. So 2 pairs of opposite sides are parallel. This little symbol that you see up here on the board is the symbol for parallelogram. So when you name a parallelogram, you can put that little symbol in front of it and then name it using its vertices. Again, always go around your shape consecutively. Do not name this A, B, D, C, because that does not make a parallelogram when you connect those. A, B, D, C makes an N. So make sure you always go consecutively around your shape, okay? Any questions about naming or the definition? All right, let's think about some other things you know about a parallelogram. When you look at a parallelogram, the opposite sides are going to be parallel. What else do you think is going to be true about the opposite sides? Who said that? Very good. The opposite side should be congruent. That's your next property. The opposite sides will be congruent, and I'm just going to use my little congruent symbol. So that means not only are the opposite sides parallel, but the opposite sides are congruent. If you're looking in your notes, that's this next theorem here, that the opposite sides will be congruent. Okay? Think about your parallelogram. Go back to chapter 3 in your mind. If you have two parallel lines cut by a transversal, what do you know about these two consecutive angles here? They're supplementary. If these two lines are parallel, what would we know about these two consecutive angles? Supplementary. What would we know about these two consecutive angles? Supplementary. And lastly, these two? Supplementary. What kind of angles are these called when they're in between the two parallel lines? Same side, interior. Okay, so another property about your parallelogram is right here in your notes. Consecutive angles will be supplementary. So add that to your list. Consecutive angles are supplementary. Consecutive angles are supplementary. So every pair of angles side by side should add to be 180. So for example, if this is my picture up here on the board, this angle is 120 degrees. What is the angle next to it to the right? 60. If this angle is 60, what's the angle down below? 120. If this angle is 120, what is the angle to the left? 60. Because every pair of consecutive angles has to be supplementary. So now what do you notice about the opposite angles? They're congruent. That's your next property. Opposite angles are congruent. Opposite angles are congruent. So far we have 4, right? Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. There are 5 properties for the parallelogram. The 5th property is right here in your notes. What does it say is true in a parallelogram? The diagonals bisect each other. What does it mean to bisect? Okay, cut in half. What's a better definition? Two congruent parts. Split into two congruent parts. So if we think about our picture up here, if I draw in each diagonal, those diagonals are going to split each other into two congruent parts. So this piece is going to be congruent to this piece. This piece is going to be congruent to this piece. So the 5th and final property for a parallelogram is the diagonals bisect each other. So you're going to have to memorize these 5 properties for your parallelogram. Some of them I think will be common sense and you'll automatically know those things are true, and some of them you'll have to memorize because maybe you had never thought about it. Okay? And then you're going to use the properties to answer questions and find missing measurements. So first of all, when you look at this example, how do you know this is a parallelogram? Diagonals are going to intersect in every polygon. It doesn't necessarily mean that it's a parallelogram. Okay, the symbol. If they had marked those diagonals being bisected, then you would know it was a parallelogram. But they haven't shown us that those are split into two congruent parts. The symbol right here means parallelogram. Okay, so watch for that. They're going to tell you. So we know this is a parallelogram, which we know means we know these 5 things are true. What do they want us to find here? CF. Okay, that's this side right here. What should CF be the same as? DE. Because opposite sides are congruent. What is DE? 74 millimeters. So what is CF? It is really that easy. You just have to know the property. Do I put a line segment above CF when I'm saying what it is equal to? No. Don't let little things like that from last semester catch you. Okay, go to your next example. Same picture. So we know it's a parallelogram, same information, but this time what do they want us to find? Angle EFC. So go to your picture and find EFC. So we're looking for this big angle right here in our parallelogram. What other angle measure do they give us? FCD. How can I use that to answer the question? Very good. I don't know if you guys could hear Elijah, but he said we know that consecutive angles are supplementary. So that means we know that these two angles should add to be 180, which means we can just simply do 180 minus 42. And what do we get? 1 what? 38. And that's the measure of angle EFC. Make sure you're using correct notation so that you don't miss points. Any questions? All right, what's left in our notes there before the proof? Okay, let's look at the next two here. Oh, that was DF. This was in your notes too, right? Okay, let's look at this one, DF. Why don't you guys go ahead and try this one? Actually, try the next three with you and your partner. I'm going to give you a few minutes. See if you can answer the next three. And then we'll check them. I'm coming around, so if you get stuck, ask me. Okay, if you're not quite finished, that's okay, but we're going to go ahead and check these three. Hopefully you can at least get them set up if you haven't solved. So what property did you use for this one? Which property? Diagonals bisect each other. If the diagonals bisect each other and you know that DG is 31, then that means GF had to be 31, and so DF had to be 62. Any questions on that one? Okay, next one. What property did you use to find YZ? Careful, to find YZ, what property did you use? Opposite sides are congruent. So that meant that you should have set this side equal to this side and solved for A and then substituted it back in. What did you get for A? 7. When you substituted it in, what did you get for YZ? 44? 52? Let's check. So A should have been 7, and it should have been 52 when you plugged it back in. Questions on that one? Are we good with those who got 44? Okay. Next one, what property did you use to find angle Z? Okay, consecutive angles are supplementary. So you took these two angles and what did you do with them? Added them and set them equal to 180. So if you did that, what did you get for the value of B? For B, 7, and then plugging it back in, what did you get for angle Z? 65. So B is 7, the angle is 65 degrees. Questions on this one? Okay, we have about 6 minutes. I want to do the last example that's not a proof. There are no proofs on your homework. There will be proofs on your test. So when we come back on Thursday, we'll go over the last 2 examples that are proofs, okay? But I want to do this last example here. So if you'll turn to this last one before the proofs. Okay, so first of all, when you read this, what tells you what kind of shape you have? The symbol. The symbol tells me that this is a what? Parallelogram. Watch for that because we're going to learn a lot of other quadrilaterals, and this is the symbol for parallelogram. Okay, I gave you a graph, and I already graphed the points for you, right? Everybody has a graph? So it says, given these coordinates, find vertex M. If we know this is a parallelogram, what do we know about the opposite sides? We know they're congruent. What else do we know? Help me out, guys. Definition of a parallelogram. What's true about the opposite sides? They're parallel. Opposite sides are parallel. What do we know in Algebra 1 on a graph about parallel lines and their slopes? They have the same slope. So if I want to figure out where my missing vertex is, I need to use the fact that opposite sides are parallel and that parallel lines have the same slope. And then be very careful. Remember that you name your shape consecutively around the picture. If you don't look at that, you'll make a mistake and you'll find the wrong vertex point. They said this is supposed to go from J to K to L and then down to M, right? So M has to be somewhere over here. Be very careful that you don't connect J to L to K and find M somewhere down here. Read how they said to connect the dots. Okay? So how am I going to figure out where M goes? Okay, I heard, sorry, Sean, I heard Jedi say find the slope of what? KJ. I could find the slope of KJ. If I find the slope of KJ, where am I going to repeat that slope from? From L. So one way would be to find the slope of KJ and then go to L and repeat that slope. What would be another way to do it? Find the slope of KL and then go where and repeat it? J. Is everybody with me? Shelby, you with me? Okay, so I'm going to do KL. Is it okay if we do KL instead since it's shorter? Okay, what's the slope from K to L? It's kind of hard on your small little graph, right? Is it up 4, right 4? Okay, don't reduce that. Don't change it to 1 because then you're going to go down 1, right 1, and that's not going to be, oh, hold on. It's up 4, yeah. So then you're going to go up 1, right 1, and then you won't really be where M is supposed to be. So don't reduce your slope. Go from here, go up 4, right 4. Where does it land? 7, negative 4. Is everybody with me that we went up 4, right 4, and then we found M? Make sure you write your answer. M is at 7, negative 4. Questions on that one? Okay, your assignment is a worksheet. No book, no core math. However, you have to show your work. If you don't have room to show your work on here, do it on a separate sheet of paper, attach it. If you turn this into me with only answers, you will get 0 points. You have to show work. I'm going to repeat that. Just because you get a calculator doesn't mean you can just type it in on your calculator. You have to do what? Show work. I'm going to go ahead and give you a slip just because it helps you to remember what your assignment is, but you don't have to turn the slip in if you don't want to, since it's just the worksheet. This is kind of a long assignment, even though it's on a worksheet, but no proofs. No, I don't need that back. You can keep it, Jackson. Thanks. So, excuse me. Make sure you put your calculators away every day. Do not leave them on your desk. And it's okay if they're not in the right number slots because they're not quite numbered all perfectly anymore. How many people there are on this row? 1, 2, 3 maybe? Make sure if I missed you, let me know. Come on, Brent. Remember, do it tonight. Call or text me tonight. Come to tutoring tomorrow at 7 and do it in there if you have questions or if you don't get finished.